In this lesson, we're going to look at how to multiply polynomials. So first, let's do a real quick review, focusing on the distributive property. So in my first problem, 2 is outside the parentheses, so that's the number I should distribute. And I have to do it to both. So 2 times x gives me 2x, and then 2 times 3 gives me a 6. Well, since that 6 is positive, I need to add in the plus sign in between them. For the next example, negative 3 is a number that we'll be distributing, so we're going to distribute this backwards. So negative 3 times 2x is negative 6x, and negative 3 times 5 is negative 15. Now you got to make sure that you don't do plus a negative 15. It should just be a minus 15. The other way that you can do this problem is you can take that negative 3 and you can move it to the very front of the parentheses. So you could rewrite it as negative 3 and in parentheses 2x plus 5. So if you prefer to see it this way, you do have that as an option, and I should get the same answer. So negative 3 times 2x is negative 6x, and negative 3 times 5 is negative 15. Now in the next example, a lot of times students want to distribute the 3x to the 6 and the negative 8x, but we have to remember this is actually a monomial times a binomial. So distributing that that 3x really isn't going to help us out here. What we're doing is we're changing a subtraction problem to a multiplication problem. So instead, we're going to reset. We're going to add in the negative 1 before the parenthesis and distribute the negative 1. So negative 1 times 6 is negative 6, and negative 1 times negative 8x is a positive 8x. And then the 3x we just drop down. Nothing happens with it just yet. So from where we are now, we always have to make sure that we're combining our like terms. So 8x and 3x would be our like terms. 3 plus 8 would give us 11x, and then the minus 6 just drops down. In the last example, we're going to start working with more of these exponents, and I'm going to add in the x to the first there so I don't forget it's there. So when we distribute, don't forget the coefficients we just multiply. So 2 times 4 will give us 8, and the exponents we actually add. So x squared times x cubed will give us x to the 5th. For the second term, same idea. So 2 times 3 gives us a positive 6, and x to the second times x to the first would give us an x cubed. So in our first couple examples, you'll see that we are going to start multiplying a binomial times a binomial. So the easiest way to do this is when you look at your x plus 3, I'm going to forget that the 3's there, and I'm just going to worry about distributing the x. So then x times x, remember that's x to the first, I add those, I get x squared. And then x times 4 would give me 4x. And then I'm going to reset. So I'm going to put the 3 back in there, and instead I'm going to forget about the x, and I'm going to distribute the 3. So 3 times x is going to give us 3x, and 3 times 4 gives us 12. Now you'll notice, even though I have all of my terms, I do have like terms in the middle again. So x squared, 4 plus 3 is going to give me 7x, and then the plus 12 drops down. For our next example, 2x minus 1 times 3x minus 3. So I'm going to start by forgetting about the negative 1 and distributing 2x like normal. So 2x times 3x would give me 6x squared, because don't forget, there's those little ones there that you add. And then 2x times negative 3 is negative 6x. And then I reset. So I'm going to bring the negative 1 back in, and instead I'm going to forget about the 2x. So negative 1 times 3x, and negative 1 times negative 3. So I end up with negative 3x and then plus 3 when I do the negative 1 times negative 3. So middle terms happen to be like terms. So 6x squared minus 9x when I add those, and then plus 3 at the end. Now that's just basic FOIL from last year. The other thing we'll see is when we have some binomial squared. So what this means is that I have two copies of that base. So the easiest way to do these is to write that base 2 times. So x minus 2 times x minus 2. And now you can see I have a binomial times a binomial. So doing the same thing, I'm going to distribute the first term first. So x times x is x squared. X times negative 2 is negative 2x. And then I'm going to distribute the second term. So negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. Again, I have those middle terms in the middle that are like terms. So I get x squared minus 4x plus 4. And then our last example is the same. We just have more exponents in there. So again, I have two copies of that base. So 3x squared plus 4. And then my second copy, 3x squared plus 4. And I distribute like normal. So the 3 times the 3 gives me a 9. And the x squared times x squared, remember I add those, I get x to the 4th. Then 3x squared times 4, so 3 times 4 is 12, x squared. And then I distribute the 4, so 4 times 3x squared is going to give me 12x squared. And 4 times 4 would give me a positive 16. Okay, I have to look for like terms again. So my final answer is 9x to the 4th plus 24x squared plus 16. So now that we've tried some practice problems together, I want you to try some practice problems on your own and see how you do. So try all 5 of these, pause the video, and then when we come back together, then I'll put the answers on here and you can double check to make sure they're right. So here are your practice problem answers. So for problem number 1, your final answer is x squared minus 3x minus 40. Practice problem number 2, you have 6x squared plus 8x minus 8. Now the third practice problem, after you did your original distribution, you get a negative 7m and a plus 7m, which adds to 0, so you actually don't need to include that at all. So your final answer is m squared minus 49. For your fourth practice problem, remember you had two copies of this binomial, so you have to write it twice. And final answer, 4x squared minus 4x plus 1. Now the fifth practice problem might have been a little bit rough, so we're going to do that together. I have 1, 2, 3 different polynomials that I'm multiplying. I'm just going to go left to right. So distributing the x first, x times x gives me x squared, and x times 3 just gives me 3x. Now I have to make sure that this stays in parentheses, and then I'm going to drop down the 4x minus 7. So I'm going to reset and start again. X squared times 4x is 4x cubed. X squared times negative 7 is negative 7x squared. And then once I distribute my 3x times 4x is a positive 12x squared. And 3x times negative 7 is negative 21x. Again, once I do my distributing, I got to check and see if there's any like terms. So if I combine those, my final answer is 4x cubed plus 5x squared minus 21x. So now that we looked at some practice problems, let's look and see what they're going to look like on the keystone. So you know they love to take things and merge them together. So here it says write an expression to represent the area. Remember that expressions have no equal signs. So here I have the area of a rectangle. So area is length times width. So the length of my rectangle right now is h plus 4. That's got to stay in parentheses. And my width is just h. Now this is an expression. There's no equal sign. I'm done for part A. In part B, they say write a polynomial expression, which means I have a couple more rules here. Basically, just get rid of the parentheses. So if I bring my regular expression down, and I want to get rid of the parentheses, I do that by distributing. So I'm going to distribute backwards. So h times h would give me h squared, and h times 4 would give me plus 4h. And that's it. That's your polynomial expression. Now sometimes, instead of working with rectangles, they'll give you other shapes, like a triangle. So again, I want to write an expression to represent the area. And the area formula for a triangle is 1/2 base times height. So I have 1/2. My base in this particular triangle is a squared minus 1. So it's got to stay in parentheses because it's all one piece. And my height is 4a. Now as far as just writing an expression, I'm done. But in part B, they want to turn it into a polynomial expression, which means no parentheses. So I'm going to rewrite my original expression from part A so that I just have space to work with it. Now even though I could work from left to right, in multiplication I don't have to. I'm going to just drop the 1/2 down and kind of work with it at the end. So instead I'm going to distribute that 4a. So 4a to the first times a squared would give me 4a cubed. And 4a to the first times -1 would give me a minus 4a. And now at the end I'm going to distribute the 1/2. So half of 4, well that would just give me 2, and the a cubed drops down. And half of -4 would be -2, and the a drops down. Again, there's your polynomial expression.